to complete one oscillations, one oscillation. So one oscillation, let's just go to it again. Is it one oscillation is the movement of the mass from here over to here, right? Remember this? And then it will return back to its original position. So it looks something like a cycle. So it is repeating, it's constantly going back and forth. One oscillation is moving from here to here and back to here. That is one. So it will look
Yes,
something
sir.
like this. 1, 2, 3, 4, 5, and it will continue. All right.
Yes, sir.
All right. So we took out the important data. We took out length, and we said length goes on the x-axis, and period squared goes on the y-axis. Right.
Yes, sir.
Y-axis. All right, so we plotted our values and we drew a straight line. Last class, we drew a straight line. We should try and get most of the points on the line. All right, try and get most of the points on the line. So it'll do something like this. All right, I'm not using a ruler now, so it might not be straight. So this is what we call a, anybody remember the name of this?
No, sir.
Simple
Uh,
pendulum graph.
yes, it is a simple pendulum graph, but the line we're talking about is a best fit line. Right, remember this?
Oh.
Yeah,
Yes, sir.
best fit line. So this is the best representation that we can get from these sets of values here. All right. And
Yes, sir.
the computer did it here, right? This looks much neater than mine, right? The computer did. Who said that?
Me, sir.
All right.
Not me.
So this is like a much better representation of the best fit line, right? Most of the points will touch the line, or they are the same distance away from the line. And I want to see this in your graphs. I will look on the graphs, right? Very soon. Now we go to the equation of a line. Now this straight line is represented by the equation of a line, right? We're going to calculate now the gradient, but before we calculate the gradient, I want to go to the equation of a line. That's what we focus on for today and for the next class. So the equation of a line is y equal mx plus c. So y is our dependent variable, x is our independent variable. Dependent variable means that it depends on x. So x, it doesn't, as x changes, you'll find that the period squared changes. So x is our dependent variable.
Yes, sir.
And y is our this is our independent variable. Sorry, independent variable, and this is our dependent variable. Right?
Yes,
So
sir.
as the length increases, you'll find that the period squared will depend on our length. So you'll find out that it will start to change as well, right? Because of the length. Because of the length, it will change. So we make x our independent variable, which in this case is the length. And the dependent variable, period squared. Right? Now we'll go now. M is called our gradient and C is our y-intercept, and we'll talk about these two important points now. Right? These two important points. So y-intercept is the point at which the graph crosses or intercepts the y-axis. So we have a graph looking like this. Have a graph looking like this, and our best fit line or our linear graph looks something like this. Let's say this is 0, 1, 2, 3, 4, 5. Where is our y-intercept? Or what is our y-intercept in this case? So the y-intercept is the point at which the graph crosses the line. So this is our graph, and it crosses the y-axis. So where is our y-intercept?
Between the 3 and the 0. The 2.
Right. So yeah, so this will be 2. Let me just do that up over again. That over again.
Sir, question.
Yeah.
You could have become one nuclear physicist, sir, but you turn one teacher. Why?
That is not what we're talking about though. All right.
Alright,
Let's focus on the class for now. All right, so we have 0 here. 1, 2, 3, 4. Right? Now we have a graph looking something like this.
Graph looking something.
Now we have a graph looking something like this. Right? What is our y-intercept?
Between the 1 and the 2.
Right? To me, it's on 2.
Yes, sir.
Yeah.
Oh, it's on 2.
Yeah, so to me, it's on 2. So in this case, remember that y-intercept is the c.
Yes, sir.
So y-intercept c is equal to
2.
right? So it's the point at which the graph crosses or intercepts the y-axis, right? Now the gradient. Now we'll talk about the gradient. So it is a number that represents the steepness and direction of a specific graph, right? So I want you to tell me. So the more steep, or the steeper a graph is, it will have a higher gradient. So tell me, which one of these would have a higher gradient? A or B?
A, sir.
So A, thank you. A would have a higher gradient than B because it is much more steeper, right, than B. And it will also tell us the direction that it is going. So this would have this direction here. It has a positive gradient. And if the graph is going in this direction, it will have a positive or a negative.
Negative gradient.
Right? So it will have a negative gradient here. Are we all clear so far?
Yes, sir.
Yes, sir.
All right. Let's
Your
move on.
mic. Kadisha, your mic.
Would they play music?
What?
All right, so let's move on.
Khadija.
Let's move
All
on.
right, make sure teach now.
All right, so this was our graph before, right? What is the difference between this graph and this graph here? Look,
One
on,
is steeper than the other.
all right, look on where the graph starts then.
Yes, sir.
This one is what?
The one you start.
Where does this one start?
40.
Right, and where does this one start?
0.
Right. So we realize that most of the values are in this area, right?
Yes, sir.
Yeah, so we just cut out these values. We cut out this area right here to make, because it's wasting paper, we cut out these values right here to make it easier for us to read, and we are able to better calculate our gradient, which we go to right now. We'll go ahead and calculate our gradient now. All right, so our gradient is y2, y1, x2, x1. So basically we take 2 points on the graph. We take 2 random points on the graph, and we compare these 2 points to tell us the steepness of our graph, how steep our particular graph is. So let's try that again. We take 2 arbitrary points on the graph, this point here and this point here, and we compare them to see how steep the graph is. Is that clear?
Yes,
Yes,
sir.
sir.
All right, so this is our formula. We have, the formula is y2 minus y1 over x2 minus x1. Let's put that here. So m, which is our gradient,
Things say we go right.
equal y2 minus, what goes here?
X2.
Y2 minus y1, right?
Okay.
Over x2 minus what?
X1.
Right, so x2 minus x1. So we find, basically we find the points, these particular points, and we plug in our values in these points. So what is y2? Y2 would be the one up here. What is this value here? This is approximately 2.4, right?
2.4.
Right, it's approximately 2.4. And what is y1?
1.60.
1.6. So 2.4 minus 1.60 over, what is x2?
57.5.
Right, so we have 55 here and we have 60 here. In the middle of 55 and 60, we will have 57.5. Right? Is everyone seeing that? If you're not seeing that, please tell me. All right. So I'll take that as everyone sees that.
Yes, sir.
Yes, sir.
Okay, that's good. All right, so 57.5 minus, what is x1? No, we'll do x1 together. No, this is in the middle.
Sir, X1 is 50.
44, sir.
All right, you're close, you're close, you're close. That's a good try.
44.5.
All right, let's look at it. This is, what is in the middle? This would be the middle point, right?
Yes, sir.
Yes, sir.
Right, so what is a little bit above the middle here?
43.
Right, so 43. Everyone seen that?
Yes, sir.
Yes,
But
sir.
Yeah, so this would be in the middle of 40 and 47, 45, sorry, 40 and 45. With the middle, we would have 42.5.
yes, sir.
And then a little bit above that, we would have 43. All right, so x1 is 43. Somebody want to plug this into their calculator? Right, so what is 22.4 minus 1.60?
22.4.
Let's try that again. 2.4. 2.4 minus 1.60. What do we get?
0.8.
Sir, 0.8, sir.
Yeah, so at the top we have 0.8.
A negative 0.8.
Not negative, not negative. It's a positive value. All
What
right,
is it?
and then what we have at the bottom, we have 57.5 minus 43. What do we get?
Sir, 14.5.
All right, everyone gets that?
Yes, sir.
All right, 14.5. What's our final answer? Our final answer for the gradient?
Sir, we are supposed to add or divide.
Divide. We have 0.8 divided by 14.5.
Sir, 18.125.
0.8 divided by 14.5. We have, you sure? It's not
Sure, yeah.
14.5 divided by 0.8, no. It's 0.8 divided by 14.5.
Sir, 0.055.
Sir, 18
Or 1.
125.
It's not 18. Remember, we're dividing 0.8. We have 0.8 divided by 14.5.
What a long number.
We just want the first three numbers, our first two numbers.
0.055.
Right, so we have
One.
0.05.
55.
Yeah, 5. This is our final answer. Right?
Yes, sir.
So this was a different calculation, right? I will correct some aspects of it. Why? Because we use centimeters instead of meters. All right, somebody said I'm breaking up again. All right, so all right, before we do this, right? Yeah, let's leave it here. So we have our final answer is 0.05. Are we all clear now? We understand?
Yes,
No,
sir.
sir. Paano me no see you get that?
Who is that?
Me not
Okay.
talk everything in. Me Jesus, like me dey talk to him.
All right, so I will leave as Kadisha. What are you not understanding?
The everything me blank.
Don't laugh.
I want to see now.
Kadisha, are you following? Miss Dixon? Hello?
Yes, sir.
No, I'm talking to Miss Dixon.
Yes,
Yes,
sir, but no one is here.
Sir.
All right. Were you following a while ago?
No, sir.
Right, so that's why you're not understanding.
Because the internet have a give problem. Everything come out. Me no bother with that.
Yes, sir. My is problem too. Touch it out every minute.
Every minute he come off and stop one clear.
All right, so we have less than a minute on this call. I will hang up and then we come back, all right? When we come back,
What time I come back?
I
Back at class.
we're gonna start as soon as we start the call and you join back, we'll start again. All right.
Yes, sir. Yes, sir.
Yes.
So please hurry and join.
Don't